Hi, in this problem, we are going to look at another integral question. So the question goes like this. Consider the integral I1, and I1 is given by 1 to e 1 plus x times x plus ln x, which is the natural logarithm or logarithm to the base e to the power 100 dx, and I2 is given by sine inverse of 1 by e to pi by 2. These are the limits, and it is 1 plus e sine x plus ln sine x whole raised to the power 101 times cos x dx, right? And now in the problem it is stated that if I1 plus e times I2 divided by 101 is equal to e times 1 plus e to the power 101 minus k by 101. We have to find k, right? So the integrals look a little complicated and slightly different because you can see that in this integral the limits are 1 to e, and here the limits are in terms of angles, sine inverse 1 by e to pi by 2. And here there is some trigonometric stuff in this integral. There is sin x cos x present here, and here this was pure algebraic expression, right? So one thing that you can think of here is if I want to connect I1 and I2 together, I need to sort of try to remove the trigonometric stuff here and make it algebraic, right? One obvious thing that I can think of here in the second integral is I can say sin x is equal to t. Why is this obvious? Because there is a cos x dx present. So cos x dx will directly become dt, right? And everywhere where there is sin x, I can replace it with t now, correct? That is my substitution. So also I will change the limits now. So let's think about the limits first. When x is equal to sine inverse 1 over e, sin x will be simply 1 over e, right? So that is the value of t. So the lower limit for t will be 1 over e. And when x is equal to pi by 2, then t is equal to sin x will be equal to 1. So the upper limit will be 1, right? So if I change this integral and convert it to a new integral involving t, the limits will be 1 over e to 1, right? So let's rewrite that on the next screen. So I2, which was initially looking like this, sine inverse 1 by e, and here it was pi by 2, and the integral was 1 plus e sine x plus ln sine x whole to the power 101 multiplied by cos x dx. In this, I have put t is equal to sine x, and the limits of t are going to be from 1 by e to 1 now, right? Because if x is pi by 2, sine x is going to be 1, upper limit. So this integral becomes 1 by e to 1 plus e times t plus ln t whole to the power 101 dt, right? Okay. So now think about it. My initial integral I1 was something like this. 1 to e 1 plus x plus ln x whole to the power 100 dx, right? Here I have et plus ln t plus 1. So what I can do is I can write 1 plus ln t as ln e plus ln t, and this becomes ln et. And therefore, this expression can be written as et plus ln et whole to the power 101, right? So at least that makes the whole thing slightly similar to this, because You can see here also there is x plus ln x. Here I have et plus ln et, right? So basically that gives me the hint that maybe I should take et as my variable. A new change of variables I will do, and I will say z is equal to et. And if z is equal to et, dz is going to be e times dt, right? So that implies that the dt here will become dz by e, right? So let's change it now. And I will also change the limits of this integral. So what I will get is inside here, instead of et plus ln et, I get z plus ln z whole to the power 101. Instead of dt, I will put dz by e. And up top here, the limits, when t is 1 by e, z is equal to et will become 1. And when t is 1, it will be e. So notice that now I have converted I2 and I2 starts looking very much like I1, right? And I can write this like this, e times I2 is equal to 1 to e. This e was a constant, it comes out and it can go on the other side. So e times I2 is 1 to e z plus ln z whole to the power 101 dz, right? So this is the result that I have gotten after doing these two change of variables on I2, right? And now it looks very much like this integral, except the power here is 101 and the power here was 100, right? So the way to simplify this would be to try to do a by parts integral for 1. So I will do it like this. Let's say I1 is equal to 1 to e 1 plus x plus ln x to the power 100 dx. And I have already gotten ei2 is equal to 1 to e z plus ln z whole to the power 101 dz. And by the way, the variable name doesn't matter. So technically I can write it in terms of variable x also. So I can say x plus ln x to the power 101 dx. That is my ei2. So we'll use this condition here. Somehow we have to connect them, right? So think about it. If I take this as a variable, my derivative of this would have been 1 plus 1 by x, right? But I don't have that, I'm somewhere here. So what I can do here is I have a 1 plus x. If I take x common, I will get 1 by x plus 1 and x plus ln x to the power 100 dx, right? What is the benefit of doing this? 1 by x plus 1 is the derivative of this. So now I can say that this whole integral is easily calculatable. You can easily evaluate this second part integral. The integral of x plus ln x to the power 100 into 1 plus 1 by x dx will be simply t to the power 100 into dt. So that is going to be t to the power 101 by 101, right? So this integral is easy to find and it is going to be x plus ln x to the power 101 by 101. How do I know that? Because I can take this as t and this part becomes dt, right? So this is the answer for the integral here. So one of the terms here is easy to integrate. So this becomes my second function. This becomes my first function and I will do by parts now. So when you do by parts, you will say first function has to be kept as it is. Integral of the second function is this. So I get x plus ln x to the power 101 by 101. Evaluate this from 1 to e minus, I will differentiate the first function, which is 1, and I will keep the second function as, I will get the integral of the second function here, right? So I will get x plus ln x to the power 101 by 101 dx here from 1 to e, right? So that is going to be my I1. I1 was equal to this and I1 is still equal to this. Now, if you think about it, the calculation of this will become E. So let's do the simplification now. So I1 is coming out to be I1 is coming out to be E into E plus ln E is 1. So 1 plus E to the power 101 by 101 minus, when you put 1, you get 1 into 1 plus 0 by 101 to the power 101. And subtraction, you have 1 by 101 integral 1 to E x plus ln x to the power 101 dx, right? But this part is clearly EI2, right? So I'm getting I1 is equal to E into 1 plus E to the power 101 minus 1 by 101 minus 1 by 101 into EI2, right? So clearly I can multiply by 101 on both sides and I'll get 101 I1 is equal to this. So, or actually I don't need to do that because the question asked us something else. This was coming as EI2 by 101. And I'll just take this to this side and I'll get I1 plus EI2 by 101 is equal to E into 1 plus E to the power 101 minus 1 by 101, right? And the question was asking us the value of K, and our K is this 1. The expression in the question said E into 1 plus E to the power 101 minus K by 101. So our answer for this question is K is equal to 1. So technically the problem is not very difficult. You have to see the form of I1 and the form of I2, and you should recognize that 1 plus E sin x plus ln sin x to the power 101 cos x. Obviously, we should take sin x as t. And once you take sin x as t, you'll get 1 plus Et plus ln t to the power 101. And then 1 and ln t can be combined and it is ln et plus et. And here you had x plus ln x to the power 101 into 1 plus x dx. So this looks to be in the same form as this. And again, I took a change of variable z as et. After two changes of variable, I got here e times e2. The limits also converted nicely and it became 1 to e x plus ln x to the power 101. After that, it was simple. The idea was this was power 100 here. The idea was just do integration by parts on this. But first construct the 1 by x plus 1 term by taking x common from the second factor, right? So not very difficult once you actually start trying the problem. If you look at it in the beginning, it might look daunting, but you have to keep persevering and keep trying. So if you try it out, it actually boils down to a simple solution itself. So that's it for this video. I hope you learned how we manipulated the second integral and made it look like the first one. So such things you will also encounter many times in problems. I'll see you next time. That's it for this one.